Okay, we're going to start talking seriously about some advanced Rails stuff, and we're going to start with drying out some of the model view controller facilities we've already seen. We've been saying over and over again in the course that don't repeat yourself is a good idea. Have one place where some piece of knowledge is expressed, and don't cut and paste that knowledge all over the place, because then when you change it, you've got to change it in a lot of places. So here's an example, and this is the kind of thing that comes up in a lot of apps like this. You want to enforce some validity constraint, let's say, on your model. So a simple example is movie names have to be less than 40 characters. It's kind of a trivial example, but how would you implement that in a typical app? Because there's probably a lot of different ways that movies could get created or updated or edited. And one possibility is you have a check function that checks whether the validity constraint is satisfied, and you try to call it. You try to figure out all the places in the app where it could be called. But of course, that's hardly dry, because first of all, you probably missed one. And second, if not, you're going to miss one the next time you modify the app. And there's another place where this has to happen. So the motivating concern here is, how do we dry out things that are cross-cutting concerns, things that logically you think of as a single type of functionality? Like, we want to enforce a validity constraint, but the places in the application where that has to happen could be spread across a lot of different locations. So before I tell you how this happens in Rails, I'm going to give you a caveat. There was a very famous letter to the editor submitted to Communications of the ACM in 1968. And basically, it was railing against something that is much less prominent in programming languages than it used to be, the idea of a go-to statement. The idea that instead of having blocks of structured programs, you'd sort of have spaghetti code where you're jumping in and out of different parts of the code. If you've written assembly language code's got go-tos all over the place. Right? Most modern programming languages pretty much eschew these, but in 1968, that's not the way it looked, and a very distinguished computer scientist wrote this very famous letter, now very famous, sort of railing against GoTo and how it made your code unreadable, and it made it hard to keep track of the control flow, and everybody should just do structured programming, where everything was strictly in terms of if and else, and everything was in blocks. Anybody care to guess who said this? We've seen his face before. This is the same guy who told us that testing can only prove the presence but never the absence of program bugs, Edgar Dijkstra. So with that as a caveat, I'm going to tell you about some mechanisms that are related to something called aspect-oriented programming, which you could argue is maybe a little bit of a violation, a little bit running afoul of what Professor Dijkstra warned us about. Nonetheless, I believe that you can be given great power as long as you wield great responsibility when you exercise that power. So I'm going to tell you about it. Aspect-oriented programming is basically a set of ideas around how you could take a cross-cutting concern, like the idea that you validate something even though the act of validation might happen in a lot of different places. How do you centralize the thing that you have to do while still retaining the ability to use that in all different places? So here's some terminology that we can use. An advice is a specific piece of code that implements a cross-cutting concern. So in our case, the advice would be, we want to check that a movie name is less than 40 characters. Point cuts are places that you want to inject that advice. In other words, even though there isn't necessarily something in the source code that says, call this validation function, you essentially want the ability to annotate the code in different places, saying, these are the places that I would like to have it called. And when you put those two things together, the advice and a set of point cuts, you get an aspect. And this is one way of drying out your code. So one manifestation of this in Rails is validations. And you saw an early example of this in the Oracle of Bacon homework. Now, we use the validation functionality in that homework outside of its normal home in Active Record. But now we're going to use it a little more cohesively to show how we can do what our goal was here. OK, so let's walk through a simple example of how this works in how you express this advice in an Active Record model. And then we'll talk about how it's actually implemented, how it really works. So here's our expanded movie class. And I've got a list of ratings. And now I have a declarative list of the things that are required for a movie record to be considered a valid record. I have to say that it has to have a title. The title can't be empty. It has to have a release date. In fact, I'm going to add a couple of concerns here, like I can only enter movies that have a release date of 1930 or later. And here, I'm actually giving the name of a method that I have provided that would call a specific validation to check on a certain aspect of the model. So you can see that what I'm doing is I'm specifying these declaratively. And in fact, I have an example where I actually I cut and pasted all this stuff into a Rails console. So we can grab, OK, so I just cut and pasted that code into my Rails console window. And you can see that valid returned false. I can start asking about why the validation failed. And one of the things you get for free from Active Record is every model automatically has an errors object, an errors attribute, that tracks all of the things that didn't pass validation. So I can also ask specifically about errors on a particular attribute, like so. Or I can just ask for all of the messages related to all of the attributes. So let's take a look at how this actually happened and how this helps to dry out the code. Why is this kind of like aspects? Okay, so validation is clearly an advice, right? We declaratively stated some things that need to be true about a valid model. And there's many places in the app where a model might be updated, right? That when do we care to check these conditions? Well, basically, anytime we're going to either create a new model or change the attributes on an existing model, we would want to check that the changes are valid. So the question is, where are the point cuts here? And this brings us to the idea of model lifecycle callbacks. This is what you can think of as Rails' very limited implementation of a certain type of aspect-oriented programming. What actually happens when you use the active record calls like create or update attributes is that before they actually do their thing and talk to the database, there's a number of hooks that are provided where you can essentially cause other things to happen. They're called callbacks, lifecycle callbacks. So for example, when I do a create, what really happens is I'm doing a save of a new record, a record that's never been saved before. There's a before validation callback that I can supply. There's a before validation on create callback. So why would I want to supply something like that? Well, suppose I had a validation that said the state has to be one of the 50 United States. Well, a stupid thing to do would be in case that if the user accidentally inputs lowercase instead of uppercase for a state abbreviation, before running the validation, I could run some simple canonicalization, like uppercase some of these things. So the idea is that these are all places where you can supply a function saying, for this type of model, as you go through the life cycle of trying to make changes or create a new one, these are a bunch of functions that I can provide to control what happens at that point. And validation happens at a specific point in this cycle. So I have control before validations happen. After the validations have run, assuming they're successful, I can do other things. So an example of what might I want to do after validation, I might want to create a separate audit record that says, I'm about to write this to the database. I might want to have a log entry that says what's about to happen. But the idea is that this is a limited version of aspect-oriented programming because we don't get to decide where the point cuts are. The point cuts have been determined to be, this is where validations are run, and these are the other specific places where you can add your own functionality. So when you call valid explicitly, validation gets triggered. You could do that. That's what I did in the Rails console. You can rely on validation being called automatically whenever you're going to create or update any object. And remember that I said earlier, anytime that you're going to modify model information in the database, if you're doing it via one of the active record calls, they all sort of have to funnel down one of these two paths. And both paths include the ability to call validation. So that's the sense in which it's aspect-oriented, right? You don't have to declare every place that a model is edited in your code that validation is going to happen. But because we're seeing how Rails has chosen to expose this point cut, we know that it happens at that particular time. What happens if validation doesn't pass? If any of the validations fail, then save will fail. And if you called save bang, then it'll throw an exception, of course. And you get this errors attribute that is part of every model that actually has a number of interesting behaviors of its own. But basically, it lets you query or modify information about where the errors occurred. And you could use that to display something helpful to the user. There's a good screencast that goes along with this that you'll find linked from the book, too. What's another example of? So let me just, very quickly recapping. The reason that we think of this as kind of aspect-oriented is because nowhere in the code in a typical active record model are you going to find something that says, call the subroutine that does validation. It's implicit that it's going to happen along these two paths. And in a moment, I'm going to show you another example of this with controllers. After that, we're going to talk about why this sort of runs a little bit afoul of Ezra Dijkstra's warning about goto considered harmful. And as a preview of that, if goto is bad, think of this as come from. Like you find yourself in a validation method, and how did you get here? Because there isn't a call to that method that's obvious anywhere. You just have to know that when you save a model, the life cycle is such that validations are run at a certain point. So that's why I'm saying this is something that has to be used with caution. When we talk about pitfalls related to this aspect-oriented approach, this is one of the things we'll come back to. So here's another example. We just talked about an example where you're checking something like constraints on a model. What about constraints on calling a controller action? And the classic example of this is in most interesting applications, there are certain actions you can only do after you have logged in. There are other actions that anybody can do whether they're logged in or not. So what you'd really like to do is, rather than putting a specific check in front of every action that requires you to be logged in, you would like to declaratively say, the following list of actions should actually do some check before calling the actual controller method to make sure, let's say, that the user is logged in. So let's take a look at an example of one of those. These are controller filters. Here's sort of a classic example of a use of a controller filter. The idea is that I want to set a filter for any action and any controller action that requires you to be logged in. So I'm declaring a before filter, which means this is something that's going to happen before the controller action is called. Which controller actions does it apply to? Well, we're saying it applies to everything except whatever action is matched by this route. And I could have used a route helper here, but for simplicity in this little example, I didn't. And the before filter that I'm going to call is a function that I'm going to provide called setCurrentUser. Notice where I'm putting this filter. I'm putting it in application controller, which is the parent in the class hierarchy sense of all of your application's other controllers. So when you put a filter in application controller, it'll apply to all the actions across all the controllers. The other thing is you can put filters that are controller specific. So for example, they only apply to actions on movies, let's say. So in this action, what are we doing? Here's my method called setCurrentUser. And I'm going to assume that there's something in the session. And a little bit later, we're going to talk about single sign-on and user authentication and how you would get the session to remember that the user has successfully logged in. But for the moment, let's assume that we have that mechanism. And let's assume that if the user has successfully logged in, then there's a user ID property in the session that we have set to be the primary key of the logged in user. If the user hasn't successfully logged in, we're going to assume that this session key is going to be nil. It's going to be blank. So what I'm doing is I'm setting the current user, assuming it doesn't already exist. Remember, this double bar equals has the Ruby semantics of if current user already has a value, this doesn't change anything. But if it doesn't have a value, or if its value is nil, then it'll try to find the moviegoer whose ID matches session user ID. If session user ID happens to be nil, find by ID of nil will return nil, so this is still a safe thing to do. So after this line 6 has run, current user will either be nil if it's unable to find anybody who's successfully logged in, or else it'll be the record corresponding to the currently logged in user. And then what can I say? Well, if we don't have a currently logged in user, then I'll redirect to login. So notice that inside this filter action, this before filter, I'm doing a redirect. That means that I have stopped the show. Okay, this means that the regular controller action that was going to run when this before filter was triggered doesn't get to run because I have terminated things with a redirect. So there's a variety of things that you can do in a controller filter. And again, this is one of the reasons to be a little bit careful about how you use them. Control filters can actually change the flow of execution. So a very common failure mode when you're trying to test out your app is you write a URL that you think is going to trigger a certain controller action and something totally different happens. And the reason something different happens is somewhere you have a before filter that unexpectedly got triggered and it changed the flow of control based on some condition. So how can you change the flow of control? Well, in our example, we used redirect to. A controller filter can also render something. And the thing to remember, as we talked about very early on in the game, is request-reply protocol, right? As soon as we do a redirect or a render, the game is over. This action is done. So before filters can have the effect of preventing a controller from actually doing anything unless the controller filter's conditions are met. And of course, when this kind of thing happens, even though I didn't show it in my example, you probably want to, for example, put something in the flash so that when you redisplay that redirected page, you can show the user, this is the reason that the action you specified didn't actually occur. It's because you're not logged in. Please do that. Otherwise, the user will basically see a silent failure, right? They'll get taken to a different page than the one they thought they were going to, and they'll have no reason, no explanation of why that might have occurred. So comparing validations and filters, they're both a way to help dry things out because you can declaratively specify what you want to have happen rather than sprinkling calls all over the place. They're both point cuts in the aspect-oriented programming sense, but Rails has chosen where the point cuts are. We don't get to change that. In the case of validations, there's a well-defined lifecycle where these different hooks are called when a model is going to be saved. Those are the points at which you can intervene. One of those points is when validations are called. In the case of a controller filter, you can define filters that go before a controller action. You can also define filters that go after a controller action. An example of why you would do something like that is, again, after the successful completion of a controller action, you might want to record in a log, I just did something, so that you have a way to cross-check later on. Validation can't change the flow of execution. Validation can fail or not. You've got to write your own code to handle what happens when validation fails. But filters actually can change the flow of control. They can cause things not to happen. We can provide pretty much an arbitrary function for validation. There's a lot of common cases provided for you, like validating that a string is no longer than a certain amount or a number is within a certain range. But anything that you can code, you can validate. And when errors happen, in the case of model validations, you can look at the errors object to see what exactly went wrong. In the case of a controller filter, you have the code that's checking the conditions, so you probably ought to capture information in the flash or the session about what went wrong so that you can use that to display something useful. And as I said, the difficulty here is that it can make code harder to debug, right? You can find yourself with a controller action that apparently never gets called. In fact, at office hours, I've helped debug a lot of cases like this, where somebody will say, I'm clearly, my route is correct. My route's supposed to take me into this controller action. I'm putting a debugger breakpoint in the controller action. But when I run, I'm not hitting the debugger breakpoint. What happened? Well, it's not that you're not hitting the debugger breakpoint. It's that you're never getting to the controller action because you've got a filter earlier on that's actually stopping the show somewhere else. So here's a question about how these are implemented. Now that you know all about Ruby, which Ruby language features allow the kind of dryness that validations and filters give us? We have seen higher order functions in Ruby. We've seen closures. We've seen metaprogramming. So which combination of these arguably is supporting validations and filters?